acids and bases can be classified as being either strong or weak. The difference between strong and weak acids and bases only has to do with how separated they become in water. Strong acids and bases separate completely into ions. Weak acids and bases do not separate completely into ions, and they stay mostly intact. So let's look at this a little bit more closely with some individual strong acids and weak acids and strong bases and weak bases. Hydrochloric acid shown here is a strong acid. The first reaction is the more complicated way of looking at it, where the water molecule picks up the proton. And so we'll go through that one, and then we'll go through the next. Hydrochloric acid will react with water to produce a hydronium ion and chloride. It is a strong acid because hydrochloric acid no longer remains intact, but all of it becomes hydronium ion and chloride. You can simplify this and leave the hydronium ion argument out of there and just go ahead and look at hydrochloric acid will separate into protons and chloride in water, and know that the proton is not naked in water, it's picked up by water molecules. Why is hydrochloric acid a strong acid? Because there is no hydrochloric acid left. It is all in the water as ions. Now, just to go ahead and give you some practice, look at these two reactions and identify what is the conjugate base of hydrochloric acid. If I look at the first reaction, hydrochloric acid is an acid because it produces hydronium ion. So the chloride that remains behind is the conjugate base. If I'm looking at the second reaction, I can say hydrochloric acid produces protons. So what's left over is a chloride, so that is the conjugate base. Because a strong acid dissociates completely, we just use a single reaction arrow going forward because all of it goes to completion. Common strong acids are those listed here, notably hydrochloric acid, also called muriatic acid, and sulfuric acid are strong acids. Hydrochloric acid you can get at the hardware and is often used for, let's say, cleaning bricks or concrete. Sulfuric acid, well, that's the strong acid that are in lead acid batteries. If I look at a weak acid, it differs from a strong acid in that only a tiny amount of it separates into ions or dissociates. Let's look at the first reaction, the more complicated one, where the acetic acid gives water a proton and it becomes hydronium ion and acetate. Because the majority of the acid stays as acetic acid and does not form the hydronium ion and acetate, this is a weak acid. We write a double arrow, the equilibrium arrows, to show that there is a forward and a reverse reaction. And if we were to examine this, we would find only a tiny portion of the acetic acid makes the hydronium ion and acetate. If you prefer to look at it in a simpler way, you can look at the next reaction. That's acetic acid forms a proton and acetate. We know the proton is not naked and it is picked up by water molecules. The acetic acid stays mostly intact. Very little of it separates into the proton and the acetate. Acetic acid is what we find in vinegar, and some other common weak acids are phosphoric acid and carbonic acid. Both of those you drink when you're drinking Coke. Dr. Pepper or Pepsi, any of the brown Cokes. Now, if you want some practice on doing conjugate acids and conjugate bases, acetic acid is an acid, so what is its conjugate base? Analyze these reactions and determine what is a conjugate base. Well, in the first reaction, acetic acid makes the hydronium ion, so the acetate is a conjugate conjugate base. In the second reaction, acetic acid makes protons, so the acetate is the conjugate base. Let's look at bases now. The first reaction is that of a strong base. When I put a strong base in water, what happens? The strong base separates into ions and makes sodium and hydroxide ions. Those ions are completely separated and there's no intact sodium hydroxide left behind. So it's a strong base. Sodium hydroxide, potassium hydroxide, most metal hydroxides are strong bases. If I look below at ammonia, I can see that ammonia is a weak base. A weak base makes only a small amount of hydroxide in water. The majority of it stays as the ammonia. So I can look at that and say it is a weak base because very little of it dissociates into ions. Acids and bases are defined according to being strong or weak. Remember that acid and base strength has nothing to do with their concentration. You can have a very dilute, strong acid. You can have a very concentrated, weak acid. Likewise with the bases. The difference between strong and weak has to do with how dissociated it is. A strong acid completely dissociates. Weak acid incompletely dissociates. A strong base completely dissociates. A weak base incompletely dissociates. Here's a picture of a weak acid, and the red ball is the acid, what's left behind of the acid after the proton comes off, and the blue ball is the proton. And so what I'm showing you in this picture is that in water, a weak acid stays intact for the most part. Very little of it dissociates. Whereas a strong acid is completely dissociated. The ions come apart completely and you have them floating around freely.